A ball is given an initial velocity of 8 meters per second at an angle of 20 degrees below the horizontal when it is tossed from an upper story window of a building. If the ball hits the ground 3 seconds later, part A, how far horizontally from the base of the building does the ball hit the ground? And then in B, you need to find the height from which the ball was thrown. That is the height of the building. In C, how long does it take the ball to reach a point 10 meters below the level of the thrower? As the figure shows, the initial velocity with 8 meters per second below with 20 degrees below the horizontal. If we want to find the range or the horizontal distance from the base of the building up to the location where the ball hits the ground, we need to use the equation delta x equal v naught x t, and v naught x can be easily obtained from the given information by substituting 8 meters per second for v naught and 20 degrees for theta, so that that gives us 7.5 meters per second. Now, to find delta x, simply just insert this value together with the given time of 3 seconds. That's the time of the flight. Then you will get an answer of 22.5 meters. To solve for the this is for delta x. To solve for the height of the building, we have to use the third kinematic equation, that is delta y equal v naught yt minus half gt square, where t again is the time from the level of the point of launching the ball until it hits the ground, time of flight. V naught y can be obtained easily by having the angle and the magnitude of the initial velocity, and you will get it with 2.74 meters per second with a minus sign. The minus sign again, this is because the ball along the y-axis is going downward. Now substitute these values, including the signs, into this equation, on the third kinematic equation. We'll get an answer of minus 53.2 meters. That's the displacement of the ball along the y-axis. And the absolute value of that gives us the height of the building. Now, to find the time it takes the ball to be 10 meters below the horizontal in here, at this point, call it time, this time from the starting point until here, we call it t sub b. By applying the same kinematic equation as before and substituting delta y minus 10 instead, and the time can be found easily. And also we're going to use the same initial velocity along the y-axis obtained earlier. Then the time at this point is 0.78 seconds or 0.79 seconds. This is a good training exercise for a student to do. It's the ball in this case is thrown with an initial velocity of 8 meters per second with an angle of 20 degrees above the horizontal, And as you see, the path of the ball is a little bit different from that one. It's longer. And then the time of flight is chosen to be 4 seconds instead of 3 seconds as in the previous example. Now, you are asked the same questions as in the previous example. First of all, you need to know how far horizontally from the base of the building does the ball strike the ground. That is delta x. And obviously, as you can notice here in this figure, as you can compare it with the previous one, the delta x it looks different, and we're expecting to get different result in here because the time of flight is different. The second part, B, you are asked to find the height of this building. To find the height of the building, you're going to apply the same kinematic equation, that is the third kinematic equation, as in the previous example. The only difference in here, and you can notice that the ball has two components. The one along the y-axis, v naught y, will have a positive sign, and then you will substitute a positive sign instead of negative, as in the previous example. That's why we are expecting here, because you got this difference, and the expected time of flight is different as well, or the time of flight actually given different. So we are expecting a different answer for the height of the building. And the question about how long does it take the ball to reach a point 10 meter below the level of the thrower. So to find that also, we are expecting a different time because the ball is going to go up and then going down until it reaches B. So we are expecting a time different from the previous example. And the answers in every part is given in here. This is an interesting exercise. Here we have a basketball player. He's throwing the ball from an altitude of 2 meters with an angle of 40 degrees with the horizontal towards a basket. And this basket is actually 10 meters away from him. 10 meters as given here below, 10 meters. And the height of the basket from the ground, this one, is 3.05. What is needed here from this information? What is the acceleration of the basketball at this point, at the top of the trajectory, the highest point of the trajectory? And what is the initial speed he's supposed to throw the ball with by this angle, by the given angle, this initial speed, such that it goes into the hoop without hitting the backboard. Well, the problem here, in order to solve the problem here, is we have the following information. We have this delta x given with 10 meters, and we have this displacement of delta y, where the ball go along the x-axis from the level of the thrower into the hoop of the basket. And delta y, as given, is nothing more than 3.05 minus 2. That is 1.005. So here we have this is the information we got. We got delta x, delta y, and the angle of projection. Obviously, at the top of the trajectory, or the highest point, the acceleration is minus g, or minus 10 meter per second square, as it is always like that in the whole path of the ball, because the only force acting on the ball is the force of gravity, and its acceleration is minus 10 meter per second squared. This is the answer for part A. For part B, to find the initial speed of the ball, you need to have to apply this equation, delta x equals v naught x which is v naught cosine theta naught, and theta naught 40 cosine 40, and this is multiplied by the time t. This is the first equation where we have two unknowns, v naught and t. And the second equation, we have to use the third kinematic equation, that is v naught sine theta naught, which is 40 in this case, which is 40, and that all of that multiplied by t, then minus 0.5 or half g t square. So we have these two equations with two unknowns here as well, v naught and t. We have to solve these two equations simultaneously in order to get the speed v naught, and this is the answer.